Very good morning. Today we are going to see a small problem. Kirchhoff's current. Take down this problem. Here, 20 voltage is connected to three resistors, that is 2.2 kilo ohms, 3.3 kilo ohms, and 2.2 kilo ohms. Like this, we need to verify the Kirchhoff's current law. Solution. By Kirchhoff's current law, what is Kirchhoff's current law states that the total current flowing towards a junction point is equal to the total current flowing away from the junction point. That is, I1 is equal to, say for example, this point you consider as node B1. Here the current coming inside is I1. I1 is equal to I2 plus I3. So here I1 is equal to I2 plus I3. This is the Kirchhoff's current law. Now what we are doing is we are applying the nodal analysis in this particular point. If you apply the nodal analysis in this particular point, if you consider this 20 minus V1 divided by 2.2 kilos. That means uh, higher potential you need to take first. So it should not be like a V1 minus 20 divided by 2.2 because higher potential is 20 volts. So 20 volts has to consider first. So 20 minus V1 divided by 2.2 kilovolts. That is nothing but I. Is what here is written. I1 is equal to 20 minus V1 divided by 2.2. Here at this order, next again, this potential we are considering as zero potential. So V1 minus 0 divided by 3.3 kilos. Because this potential, say for example, this potential we are considering that is grounded, and this potential we are considering 0. So V1 minus 0 divided by 3.3 kilos. Here again, this I3 is nothing but V1 minus 0 divided by 2.2 kilos. That is the I2 and I3. Here you see I2 is equal to V1 minus 0 divided by 3.3 kilo ohms. I3 is equal to V1 minus 0 divided by 2.2 kilo ohms. These are all kilo ohms that you remember. Okay, if you are not adding the kilo here, the answer may get wrong. Now we are verifying that is I1 minus I2 minus I3 is equal to 0. That is I1 is equal to I2 plus I3. Here, what is I1? I1 already we derived, that is 20 minus V1 divided by 2.2. I2 also already we got V1 minus 0 divided by 3.3. I3 also already we got V1 minus 0 divided by 2.2. Taking the common terms, that is V1 is common. Now V1 we are taking common, taking LCM for all these things. That is 1 divided by 3.3 plus 1 divided by 2.2 plus 1 divided by 2.2. Here, simplifying, we will get the answer as 1.212 V1. Here we will simplifying, it is 9.0909. Here also 2.2 kilo ohm is there, common kilo ohm. Here also 3.3, 2.2, 2.2. If you take a common outside, all is in kilo ohm. So that also kilo ohm is there. So kilo ohm get cancelled. Or otherwise kilo ohm, if you consider and you calculate also, you will get the same answer. V1 is equal to 7.5. In parallel circuit, the voltage is constant, but the current varies. How the voltage is constant? Yeah, here consider this as some here 230 volts single phase AC supply is connected. Here these are all loads. Like in home, how it will be in our house, how it will be connected. So only one voltage source is coming to the energy meter. After that, it is this and all you are considering as load. Say for example, this resistance you consider as one load. That is, say for example, refrigerator. This resistance you consider as some ceiling fan. This is consider as another one load as washing machine. Like that, all loads are connected. So one voltage source is being connected with all load. So voltage is constant. So if in the power socket available in our home, wherever you test with your multimeter or voltmeter, you'll get a 230 volt. 230 volt, but depends on the load, the current varies. So that is what here also shows. Depends on the load, the current it varies. Depends on the load type. Say for example, how many watts, 750 watts or 1000 watts or 2000 watts. Depends on the load, the current gets varies. Okay, so this is the best example for how the house wiring, how it is connected. Say, for example, in foreign countries, if you test the socket, same here, instead of 230 volts, it is 110 volts. So wherever you measure in sockets, you will get a 110 volts, 110 volts AC volt in foreign countries. In that house wiring, how it is connected, like that only this also connected. So one voltage source, that is this is, imagine this is a AC source, and all this resistance are loads. So the resistance is connected in parallel. Here, yeah, the parallel circuit, voltage is constant, but current varies. By Kirchhoff's current law, I1 is equal to I2 plus I3. Here, substitute V1 is V1 as 7.5 volts, 7.5 volts. So I1 is equal to uh, 20 minus V1 divided by 2.2 into 10 to the power of 3. So V1 is what? 7.5 volts. So 20 minus 7.5 divided by 2. So if you simplify with your scientific calculator, you'll get the answer as I1 is equal to 5.68 milliamp. Similarly, I2 is equal to V1 divided by 3.3 into 10 to the power of 3. So V1 we substitute as 7.5 volts. Here, simplifying, we'll get the answer as 2.7 milliamp. Similarly, I3, V1 divided by it is a 7.5 divided by 0.2 into 10 to the power of 3, that is 3.4090 milliampere. So I1 is equal to I2 plus I3. Here I1 is 5.68 is equal to I2 is 2.27 plus 3.4090 milliamperes. So if you add this, approximately it is equal to 5.679 milliamperes. That is approximately equal to 5.68 milliamperes. Hence, Kirchhoff's current law is verified for this particular circuit. Thank you.